Good morning. So today we are going to start with the new topic called as a Turing machine. Turing machine. Now Turing machine, this concept is introduced by a scientist called as Alan Turing. Actually, Turing machine is a computing device. Turing machine is a computing device. So what till now we have seen that finite automata, the push down automata. So Turing machine is somewhat advanced of it. So this is very interesting point. Now Turing machine, the structure is basically like this. So as we know, this is your tape, a sequential device where we are storing the inputs, where we are storing the inputs. Now Turing machine is having the tape where we are storing the input. At the same time, it will store the output onto the same Turing machine. It will modify the input to convert it into the output by some operation. And this is your finite control. Now, in this finite control, it performs the current position, as well as the read and write operation. Means suppose if the finite control is at this one, it always starts with the first character of your input. So if it is at the one, so if input is one, what we have to do? So it can keep one as it is, or it can replace one with some other symbol. It can replace this one with the other symbol. So this is called as a read. So it will read the input one. Again, it is capable of writing the new symbol onto the tape, So it can also modify the input. So that is the power of the finite control. Read write head into the Turing machine. Next thing about this finite control, in a previous finite automata and the push down automata, your finite control always move right one by one. Now here in the Turing machine, the finite head can move right, can move left, or can stay on the same place. That is a no operation, no movement. So it can move right, left, as well as it can stay on the same place. So these are the three operations. Now your finite control or the read write head in your Turing machine can do. So this is what is going to help into the actual computation of the symbols of the operation. So this is the basic thing about the Turing machine. Input tape, read write head, which is capable of reading the input or modifying updating the input, writing the input onto the tape. And the head can move left, right, or stay on the same place. So the definition of this Turing machine, we can define with the help of the seven tuples. Now the seven tuples, Q is a states, all the states will be Q. Sigma is your input symbol. Now tau is your tape symbols. So previously in a PDA, tau is your stack symbols. Here the tau is the tape symbols. Now tape symbols and the input symbol. What is the difference between these tape symbols and the input symbol? Now sigma is your input symbol which gives the initial input. So whatever we are having onto the tape initially as an input, that will be your sigma. Now tau is what? Tau is if we are replacing this one with x. So this one will be get replaced with x, some symbol. So that time x will be the part of the tau. That is what your tape symbol. Blank is one more special tape symbol. Okay. So your tau will be your input symbol, as well as what additional symbols you are using to perform the calculation, to perform the operation onto the Turing machine, onto the tape, to get the required output. That is what your tau is. So input as well as some more extra tape symbol is your tau. Del is your transition function. Del will be your transition function. Q0 is the initial state. B is a blank. B stands for the blank. Now, blank is a special symbol which will indicate the blank areas, blank cell of the tape. So we can define the tape is a collection of cells. In one cell, we can store one input, one symbol. In one cell, we can store one symbol. So blank is unused symbol, unused cells. So that is indicated by special symbol called as a blank. So that is again will require when we are working with your Turing machine. F is your final state. F is your final. So like this, states, input symbol, tape symbols, transition function. Now, what transition function is used? A transition function will define as a state with the input symbol. State with the input symbol. Okay. This is what your some state where your read write head will be and the input symbol. So from this state with this input, what it is going to do? It may stay on the same state or it may go to the next state. So whatever it will get a state with toe, that is a stack symbol, that is a tape symbol, that is a tape symbol. So toe, Q, tape symbol, and the movement, that is what your left, right, left or right or no movement, the head movement where it will move. So this will be your transition function, that is what del. State with input, so it will go to the next state, the stack, the tape symbol and the head movement. That will be left, right or no operation, that it will be on the same place. So with the help of this, we are going to represent the del, transition function. This is what the definition of the Turing machine. This is definition of Turing machine. Now we'll try to understand this Turing machine with the help of one example. With the help of one example. So we'll take one example. Now the example we say design Turing machine, TM Turing machine, which removes blanks, which remove blanks between two inputs. Now consider this is the example. This is the example. Design a Turing machine which remove blanks between two inputs. Now take an example. Here is the input is a 1 1 1. 1 is the input, so we are having the one input 1 1 1. And again second input is 1 1 1. So we are having the 2. If we are saying this is the W1 1 string, now string is made up of only a single symbol, that is the 1. So we'll say 3 1 is a one string, and this again a 3 1 is a string 2. Now these two strings are somewhat apart from each other. So in between these, there are some blanks. There are some blanks. So we have to remove these blanks. Now how to remove this blank? This is what your problem statement is. Now we have to find out the logic. How to remove this blank. So now what we can do? We can replace these blanks with one input, that is W1 we can replace here, or W2 we can replace here. So we have to remove these blanks. So how we can achieve this with the help of the Turing machine?